Check, hey, check, check. Two, check, check, hey. Okay, so oh, we've started, didn't we? Oh yeah, I don't remember that. The goal today is to just do free response question 1, and after that, you guys will have time to work at your own pace. And I suppose that means, well, who knows what that means? Who knows?
Are you screen recording this?
I am. What I learned is that when you extend your desktop, you can actually have it record like your second screen instead of your first screen, which is pretty awesome. Because then you could be watching something completely different on your first screen, but recording something completely different on your second screen. Which I should try sometime here. Yeah. Substitute Facebook with, I don't know, TweetDeck? I guess, TweetDeck. What was I doing? Oh, I was going to hear Stats Chapter 12 review. We'll just screenshot question 1 so we don't have to keep going back and forth. This is the awesome part of the video that everyone wants to see. Okay. So very, very modest goals for today. Or this morning, I should say. This weekend, Mrs. Ferreria decided that we should watch classic movie. So we watched It's a Mad World. Have we seen this before? I'm guessing no. It's like it's 2 hours and 45 minutes long. There's a lot of like old classic Hollywood stars in it, and it's basically slapstick in the high desert. I don't know. Should you decide to watch it, get a pillow. No, it was actually kind of charming. If you can deal with the way they paced movies back then it's a pretty fun movie. But they don't pace movies. They used to pace the movies like they were like stage shows, stage musicals, and it just doesn't work as well. You've grown up. That was like, yeah, see. Again, there's so much there that would have been edited out nowadays. It's not tight enough. Make it tighter. Whoa, this is totally in the wrong place. Come on. Keep going. Faster, faster, faster. There we go. There we go. Free response 1. Okay, so it is believed that the average amount of money... Wait, am I even recording the screen? Let's just make sure. Yeah, that's the screen. That's the screen. It's believed that the average amount of money spent per U.S. household per household per week on food is about. Did I not screen clip that? $98. That's really cheap. That's not a lot of money on food.
Yeah.
$98 per week. That's about $400 a month or so. I don't know. With a standard deviation of 10, a random sample of 100 households in a certain affluent community yielded a weekly food budget of $100. We want to test the hypothesis that the mean weekly food for the households in this community is higher than the national average. Okay, so is higher than the national average. What does that tell us? Yeah, it tells us it's greater than, exactly. That's our alternative hypothesis. Why am I using my... could use the pen. Yeah, higher than the national average. That should mean to us our alternative hypothesis is greater than the mean. All right, so let's go through this. Our parameter values, mu, is the...
Is 98.
No. What is mu?
No, 100.
No.
The average amount of money spent.
Average amount.
This says
Okay, what does she like? She doesn't need this.
Oh, okay.
The computer will work just fine. We can do it later.
Alright.
Unless she needs to open this. Does she need to open the door?
Wait, what?
Did she need DVD playing?
No.
Okay.
Is she, I guess it's just this that's all.
Yeah, it still works fine without that. Average amount of money spent, average amount of weekly food budget in
U.S. households.
U.S. households. Great. And X bar?
Same thing except for no sample. Or 100.
Yep. Average amount of weekly food budget in sample of 100. Great. Our hypothesis.
Equals 98.
Mu equals 98. Remember, always about mu. And our alternative hypothesis. Good. Mu is greater than 98. Two steps out of the way. Let's check our assumptions. Okay. So the first one that we need to check is SRS. Okay. SRS. The problem states random sample. Independence. Okay. So yes, there should be. There are more than 10n, which equals, is that 10,000? 1,000 households in the community, right? Wait, that's a big community, 1,000, right?
Yeah.
Right.
Okay. Remember, we're testing the mean in the community. We're not really testing it in the United States.
Right.
Okay. So there needs to be more than community.
Are we doing all of this because it says to perform a significance test?
Yep. And normality, we can definitely use CLT. Sample size, what is it? Sample size is greater than 30. the CLT guarantees a, what do we call that? Sampling distribution. That is approximately normal. Great. So we've checked that the only thing that's kind of funny is that independence one, right? Okay. Name of the test. This is a one sample. Right side, right tail. Right tail is going to be a t-test or a z-test. T-test for mean, a mean.
Why is it a T-test? When they gave us
Did they give us a,
standard deviation.
oh, they did give us a standard deviation. So that makes it a z-test. Okay. Let's highlight how we know. That is standard deviation of 10, right?
Yeah.
And that's 10 for
Listen.
so that tells us z-test. Okay. That's not the standard deviation of the sample. That's the standard deviation of the population, right?
Right.
Okay. Test statistic. Okay, so we have z is equal to, what's our numerator? The x bar minus mu. 100 divided by
And divided by square root of 100. So it's just 2.
2. Sounds like, looks like we're going to fail here, right? Hopefully you're getting a sense when you get your test statistic, you should be knowing kind of what the p-value is going to be. Okay, you're seeing a 2, you know you're going to be greater than 2. That's going to be a very small area, right? Okay, so the p-value is equal to the probability that z is strictly greater than 2. Someone have that worked out? 227, great. Yeah,
So if it's right-tailed, it's always Z is greater than.
yep,
If it's left-tailed, it would be Z is less than.
yeah. Let's draw that pretty picture there, Adam.
I'm just kind of still confused on like when we reject at what level, but since the p-value is 0.02,
Mhm.
it says 2%, does that mean you can reject it at the like 5% level?
You can reject it at any alpha level that's greater than 2%.
Ah, okay.
If those 1, you'd fail.
Yeah, so if you're testing at the 1% level, you would definitely reject.
And
Fail to
so,
reject.
You would fail to reject, yeah, I'm
and
sorry.
same with 2?
Same thing with 2% level, yeah.
Okay.
If you have a p-value that's like equal to alpha, would you fail to reject? Or reject?
You know,
Not gonna happen.
yeah, that's unlikely to happen. It's very, you know, we're trying to be, as we're learning this, we're trying to figure it out based on, you know, is this likely, is this not likely? If you were actually doing something and you're close to your alpha, you would have some kind of reasoning to, you know, you have other things that you can look at
Okay.
to make your decision.
Independent.
Yep. This is wrong. That should be 100 here, right? Okay. And the area here equals 0.0227, which equals the p-value. Okay, so we can make our decision now. We're going to reject our null hypothesis, right? Okay. So, yeah.
So I just to clarify, so if it's like, so if it would be at the 2,
Mm-hmm.
then it would be, we fail to reject it, right?
Exactly.
Okay. So as long as it's not under.
Mm-hmm. Okay, so in other words, we're going to reject the null hypothesis if alpha is greater, no, if the p-value is less than alpha. Okay? And since we're not given an alpha, we're going to,
We are.
oh, what's our alpha level?
0.05.
0.05, okay. So our p-value is definitely less than our alpha, right?
Yeah.
So we're going to reject. Since 0.0227 is less than 0.05. Okay. So 2.27% of the time of samples size 100 will produce a a mean as extreme, at least as extreme as 100 sorry, if the null hypothesis was true. Okay, so what's the next thing we need to do? Since this is not probable, we reject the null hypothesis. Why'd I put probably? So we're going to reject that null hypothesis. What does this mean? This means that our evidence suggests that the mean food budget in the community tested is, in fact, greater than the national average, and yet great. That's kind of it.
Mr. Cole?
Yeah.
So since we reject the null hypothesis, we're saying that the alternative hypothesis could be true.
Yeah.
That's why we're saying that it's greater than.
Mm-hmm.
But then,
Sure.
but I don't know how would that work?
What do you mean?
Should we just assume that the alternative hypothesis is true?
Yeah. You're not going to assume it's true. Your evidence suggests that it's true. Okay. Because remember, if the null hypothesis was true, then the likelihood of getting a sample mean of 100 is 2%, which is low. Relatively, not even relatively speaking. I mean, you're probably not going to get a random sample of 100 households that have an average of 100. Unlikely. This is actually really interesting if you think about it. We're only 2 units away. Jesus. Um, yeah, we're detecting a difference in means when there's only when that difference is only $2.
Yeah.
That's not a big difference, right? And
Right.
we're kind of able to detect that. I mean, we have a large sample, so that's kind of what helps us out here. I'm sure if we had a bigger sample, this wouldn't happen, or a smaller sample, it wouldn't happen.
So you're saying that that's the likelihood of being 98, right?
One more time.
That's the likelihood of the sample being 98 or more than that?
Yeah, that's a sample. That's a 2.27% is a probability that the sample mean would be $100.
So it's saying it's not likely.
It's not likely, yeah.
So it's more likely to be 98.
It's more likely to be greater than 98. Okay? Yeah.
We can do a significance test with a paired T procedure, the same thing, right? Is that going to be on the test? Like a paired?
It could be, yes. Okay. Any other questions on this? We're going to wrap it up for this part of the day.
B and C.
Oh, I'm sorry, B and C. Totally cheating you. B. Describe type 1 error. So type 1 is error, right? Is rejection. A type 1 error is made if
We reject a null.
yeah, if we believe the mean food budget in the community is greater than 100, than 98, thank you. But in reality, the food budget is $98. Okay. Remember, if you reject, that means that you think the alternative hypothesis is true. So type 1 means that you believe the alternative hypothesis is true when the null hypothesis is actually true. Not tested, but not tested, not in this part, not asked, but the probability of this error
It was.
is alpha. Uh, 5%. Is it asked?
Yeah.
Oh, okay. The probability of making this error is same as alpha, 5%. C. Okay. A type 2 error is made if we believe, we should change to conclude, the mean food budget is greater than 98. I'm sorry, is 98. Fail to reject. But in reality, the food budget is greater than 98.
The reason it's greater than is because of the probability.
Yeah, the hypothesis.
Yeah.
Hypotheses. Hmm?
Instead of dollar sign, it's
That's awesome. There we go. John?
You could ask us for beta only if you gave us the power, right?
Yeah, you're not going to be asked to compute beta.
Okay.
Yeah.
And then
No.
how do we reduce the probability of it?
Yeah. Two ways to reduce the probability is number one, we could reduce the probability of making type 2 error by 1, considering a mean further from the H naught, which was $98, right? Or 2, larger sample, right?
Which also increase like alpha.
Oh yeah, increasing alpha, yeah.
Yeah. Weren't there 4 ways?
There were 4 ways.
Use P before.
Or 3, increasing alpha.
What's the fourth one?
Decrease standard deviation.
The problem is you can't really decrease standard deviation. So, there are 4 ways mathematically to do it, but only 3 ways to do it in practice.
Can you go to
But you can increase alpha, right? But that's just an arbitrary.
Yeah, you can increase alpha. All right. Anything else on this? Pretty straightforward. All right, let's print it.